All right, so we are going to go over the first section for 8th grade math course. The textbook is called Course 3, Volume 1. I'm not really going to refer to that very often. I might say when we switch to the second book, but the important thing is this is the first section of this math book. So, a good part of this year should be reviewing things. Obviously, if we have questions, we can stop and work along the way. But I'm just going to hit some things. This is purely this is probably your first time watching these, at least in 6th grade, and this is me doing it, so I may not be professional or anything. But I'm going to hit things, run through it. We're going to do some practice in class, and we're just going to come back and keep working. So, just to get right into it, PEMDAS. Hopefully you've heard of PEMDAS before. There is a saying, please excuse my dear Aunt Sally. Okay, so P, as I hope you remember, stands for parentheses. The E is for exponents. The M is multiplication. Ooh. And the thing about this is let me get through the D first, then I'll stop and talk about. D stands for division, and I will erase most of this. Obviously, you need to take notes as they make sense to you. So if you all know this, you can always fast forward. But the key here is if you could say, please excuse dear Aunt Sally, or you could just say, please excuse Aunt Sally. Because of that, these two things are purely added in there, meaning I can do with one or without the other, because I can say, please excuse my Aunt Sally, please excuse dear Aunt Sally. The reason I'm pointing that out is because you can do these in either order. It can be multiplication or division. It doesn't matter which order you do those in. Same thing with the Aunt Sally. Aunt stands for addition. Almost wrote the word aunt. And Sally stands for subtraction. But just like if you were reading that, you could say, please excuse my aunt. I'm sorry, I ran out of room. Or please excuse my dear Sally. You could do without either one of these again. So same way, you can do it in either order. So remember, if you do addition and subtraction, you can just work on however they fit in the problem. So we're going to kind of run through that in this example. So first rule is parentheses. So I look and I see parentheses right here, right? So I don't care about anything else. I'm going to do that parentheses. So 5 minus 15, I hope you all know, is negative 10. Okay. Then, and just like you read, you should always work multiplication, division, left to right, addition, subtraction, left to right. Because otherwise you run into problems because of missed multiplication. But I'll show you what I mean here in a second. So anyways, I forgot the exponent, didn't I? Well, exponent's next, right? So what is negative 10 squared, right? Because notice that's on the parenthesis, so only the parenthesis gets squared. So negative 10 times negative 10 is 100, right? And we're going to spend some time these first few sections talking about exponents. Okay, now I'm going to do all my multiplication and division. This right here, even though there's not a multiplication sign, hopefully you know that means multiplication anyways when there's parentheses. So I have 300 minus 7 times 3 is 21. 24 divided by 6 is 4. Okay, so notice how I work that left to right. Right, I'm reading it just like it's on the page. Then addition, subtraction. Once again, I'm going to work that left to right. I have a couple things to show you here in a second, but I'll show you there when we get there. So 300 minus 21. 300 minus 20 is 280. Minus 1 more would be 279. Plus 4 would get me 283. So that thing that we just worked, this thing is 283. Now do note, when working left to right, if I have negative 16 plus 4, that is equal to a negative 12. It's not 20 and then you put a negative on it. This is a number, a negative is a number, and you have to remember to evaluate it as such. Remember to keep the sign with it. Something else I mentioned but didn't actually do one of, but I will mention it real quick. If you were to see a problem like this, it is important to work left to right because the correct answer to this would be 24 divided by 6 is 4 times 2 equals 8. But if you were to multiply first, you would get 24 divided by 12, which equals 2, which is not the right answer. Okay? And I can explain this a little bit better when we get the fractions, but just know that you need to work left to right, and those will work out. And I already mentioned this, but the multiplication division can happen in any order. That's the same when multiplying big groups of numbers. You can multiply them in any order when they're multiplied. So I can do, like I was thinking, I could take 2 times 4 and 2 times 4. That gets me 8 times 8, right? Because 2 times 4 is 8, 2 times 4, times that last 4, which then would get me, doesn't matter how I do this, hopefully you know that 8 times 8 is 64. I'm going to put the 4 down here so I can multiply. That gets me a 16, carry the 1, 24, so 256, right? And then, when you come over here, I thought the same thing. I could take negative 8 times 5 and negative 8 times 5. Multiply those together. Gets me negative 40, right? Then, something else to note. Even number of negatives cancel each other out, so I could cancel these two. So 40 times 40, the way to multiply multiples of 10 is you count your zeros. I have 2 zeros. What is 4 times 4? 16. And then I'm going to multiply this by a negative 8. Same thing we did before. 0 times negative 8 is 0, 0. And some of you probably know how to do lattice and other things. If you know how to do those, that's fine. 8, 12, and then bring my negative down. If you know how to do long multiplication like this, that's great too. But as long as you know how to work it, that's the important thing. The important lesson there is you can manipulate it to make it easier for you. Because you could, if you knew what negative 8 times negative 8 times negative 8 was, you could have just done those times 5 times 5 is 25, obviously, and worked that out. But we like to work these as most. I know we all have access to calculators nowadays, but I would prefer that you use by hand as often as possible. It's a good practice. Okay, we're also going to talk about factoring something. To factor something, we break it down into as many numbers as we can until they can't break down again. So when you factor, it's easy to start with the smallest thing that you think can go into it. So like 42, that's an even number, so I'm going to go 2 into it. 42 divided by 2 leaves me 21. This is a prime number, so we're just going to leave it. It's not going to do anything. We're going to go to this other one, and we're going to look, okay, what goes into 21, because 21 is not prime. 7 times 3, I hope you know, is 21. Those numbers are both prime, and hopefully you remember the word prime, or you've heard the word prime by now. It means, well, simply it means unfactorable. It means only 2 things go into it. Itself and 1. There's no other number. So like 2, 3, 5, 7, 11, all those numbers that nothing else can multiply to make them, well, nothing clean can multiply to make them. Those are all what we're looking for in those factor trees. And that's called a factor tree because it makes a little, I know you can't see me, I'm making hand motions, but it makes a tree-like form because it kind of keeps spreading down and down and down. The other big thing about this section is, PEMDAS was the first big thing. The second big thing is rational numbers. They start talking about rational numbers because all the numbers that math deals with, and even there are some other numbers that math deal with that don't fall in this, but most numbers you're going to deal with the first few years of high school even are what we call rational numbers or irrational numbers. Rational numbers means simply they can be fractions. So there was a teacher who used to work here who would say rational or fractional. anything you can represent as a fraction. So like 5 over 1, 8 over 3, 35 over 6. Anything that you can make in a fraction, even technically improper fractions or even like mixed numbers. Those are all rational numbers because in the end they could be represented as fractions. Integers are the numbers that most people can really easily pick up on. They are all the positive and negative numbers, including 0. So, 5, negative 2, 206, 0, even 12 over 2, because 12 over 2 is actually 6, right? So anything represented as a fraction but simplifies to a regular number, that is an integer. And once again, that's positive or negative, right? Whole numbers, that's anything above 0. 0, 1, 2, 3. Once again, they can be fractions as long as they reduce down to a whole positive number. These are only positive numbers. Right? And hopefully you know, probably don't, hashtag, as you all know it, was first represented as the symbol for pound, so I might use it for pound every once in a while, but also it is a symbol for numbers. So, natural numbers are more commonly referred to as counting numbers. Counting numbers, well, the easiest way to think about them is, let's draw, T. Let's draw the letter T. How many T's are on there, right? You'd start counting. You'd go 1, 2, 3, 4, 5, and if I had more, you'd keep going, right? But notice how we didn't start at 0. You didn't say I have 0, then I have 1. That's what the counting number is. Counting numbers are 1, 2, 3, because you start at 1 and you just keep going on and on and on and on and on. So, we're also going to talk a little bit about how to change numbers from fractions to decimals. If you have a calculator, that's fine on this section. Once again, it's not a big deal. To change something to a decimal, all you have to do is treat the number that's on top as if it's division. I don't have room there. I don't know what I'm doing. I'm going to clear this. Once again, if I ever go too fast, the great thing is you're watching this at home, so you can pause me and shut me up, watch it at your own speed, kind of go back over it, rewrite stuff down, and obviously you can email me or come to class and ask me any questions you have. Anyways, when you're dividing a number into something that's smaller, what you do is you just add the decimal 0, but notice that the decimal is also right above it. So how many times does 8 go into 50? 8, 16, 24, 32, 40, 48. 6 times, right? I'm going to put a 6, and that got me 48. So that, when I subtract, gets me 2. It's not done yet, so I'm going to go ahead and bring another 0 down. 8 goes into 20 twice. That's 16, right? So twice and 16 leaves me with 4. Bring another 0 down. And then 8 goes into 45 times, which is 40, which gets me 0, which is what I want. If you ever do this, though, and you work a problem and it ends up going like this, if these numbers start repeating, they're always going to repeat. So what we do is we represent that with a line over the top. Technically, you can do it like that, or you can do it like that, or you can do it like that. Doesn't matter. Wherever the repeating happens, because sometimes it can even be where the repeat happens there. So once again, you can do it over all of them or over just one set of the repeating. It doesn't matter, just as long as the whole set is covered. But anyways, that's how you do that if it doesn't work out. Sometimes they don't work out at all. If it doesn't work out at all, that's those irrational numbers I talked about a second ago. But we will get into that more in the future. But anyways, to write this as a decimal, I keep the 3. And now instead of 5/8, I have the 0.625, which is why I wrote that. Same thing with changing from a fraction to or from a decimal to a fraction, what you do is you take the decimal, which is 75, and we're going to put it over the amount of decimal places I have, which is 2. That's the number of zeros I want over 100, and then simplify that. So what goes into 75 and 100? Well, we deal with money quite a bit, so hopefully 25 goes in each of those. 75 divided by 25 is 3. 100 divided by 25 is 4. I take that 5, put it in front, and I'm done. So I won't give you too complicated on those because, well, while you can do it with really complicated numbers, the important part is you need to be able to do it on those basic numbers. Because if you do it on the basic ones, you should be able to extrapolate that to get the harder ones. We may do some harder ones in class just to kind of test us out. Okay, last thing in this section, just to give you a word problem. In a recent season, which this book was written in 2015, so sometime before then, NASCAR driver Jimmie Johnson won 6 of the 36 total races. To the nearest thousandth, find the percentage of races won. Okay, so 6 out of 36 means I have 6 out of the 36 races done, right? First thing I would do is simplify that. So hopefully we can see that 6 goes into both of those. 6 divided by 6 is 1. 36 divided by 6 is not 2, it's 6. Okay? If you can't figure that out, what you can easily also do, and the same thing on the 75 over 100, is you can break these down. So what multiplies to make 6? 2 and 3. And do your little factor tree. 2 and 18. I'm going to get a really weird tree because I have to go to the side. That's a 9, 3 and 3. And then you can cancel. Let me choose them color. Cancel things that are the same on top and bottom. So I'd be left with a 2 and a 3, which is why, once again, there's technically always a 1 up top, which is why I get 1/6. So that's just if you can't do it or if you don't have a calculator handy, that's a way of doing it if you can't see the numbers as easily. So you take that number that's on top, put it in there, put that 6 up front. Once again, since I can't go into 1, I have to add a 0 on. How many times does 6 go into now 10? Once, right? I put a 6 there, gets me 4. I want to go until either I see repeating or I get a number that works out completely. I know 36 gets me 4, which once again is going to get me 6. I see that repeating starting to happen. It's going to happen every time. So I can just do this. And it asks for percentage. This would be a great time for me to ask you guys what percentage is, but since we can't really talk, the important thing to know is percentage is 2 decimal places. So 1, 2. So we want to just go there, and then we want to round up or down based off our rounding rules, right? So to 6, round up or down? Up, right? So you would say that he won approximately 17% of the races that year, which doesn't seem like a lot, but when you think of how many racers, which I think there's 50-some, 54, 52, something like that in each race, it's kind of mean that he hogged them all. So, obviously we'll do some practice at the beginning of class. If you have any questions, you can always email me. If you want to save until class, that makes sense too. And we can talk about them, work through them, and then do some practice in class. Have a good day, and I'll see you tomorrow.